I believe we are up and running now. So, the first question, they want you to draw that triangle and then tell us what we have. And remember, you're looking for the ambiguous case. What was the ambiguous case? What did you have to have? Say it again. ASS, the ass casing, or SSA, whatever you want to call it. So, as long as we don't got SSA or ASS, we're okay. So if we draw our picture, just draw any old triangle you want. Remember, the capital letters go at the vertices. The smaller letters have to go across from their counterpart. So I always start with A over here, and then I work my way clockwise. So those are my two big angles, and little a has to go across from big A. So with that being known, what is it that we have? Angle, angle, side. So the question is that the ambiguous case? No. Only ambiguous if you have the side-side angle or the angle side-side, however you want to call it. And as we're rolling through this, if you have anything that you got questions over, you just got to ask, guys. Okay? Nothing wrong with that. I'm not stopping the video or the sound or the recording, none of that. Just going to keep rolling. Okay? So they want you to find the length of side A. We're not using a calculator. So again, question 1, question 2, question 3, 4, 5, 6, and 7 all come from 11.1. So these are all law of sine problems. So question 1 through 7 all come from 11.1. These are all law of sines. So this problem is all about using the law of sines. And if you look at this, it makes sense because what we have is angle, side, angle. And law of sines is the only thing that works for angle, side, angle. Say it again. That's up to you. So if you want to know when to use law of sines, when to use law of cosines, you do that for your note card. You remember the only thing that I'm putting up on the board is the trig function chart. Okay? So that's for your note card to whatever you need. All right. So law of sines. Well, we're going to need to know what this angle is first before we can do anything. Because law of sines is all about proportions, and the angles and their opposite sides have to match up with each other in order to do law of sines. So how do we find this missing angle B? You got it. Take our two angles, the 45 degrees and the 105 degrees, add those two bad boys together, and we're going to take that away from 180 degrees. So what is the measure of angle B going to be? 30? Perfect. And the reason why it says do not use a calculator is because we know what that angle measure is going to deal with. We're also going to be using the 45-degree angle as well.
Wait, is it the same one?
So, so let's set up law of sines. Obviously, we're looking for A. So that's going to be A over sine of what angle? Which is A, which is 45. Yeah, you both got it. 45 degrees, and that has to equal, well, yeah, you got to use your other side, which is the 6, and the sine of 30. So this is why it says to not use the calculator, because we know what sine 45 is and sine 30. Remember, that information will also be up on the board for you guys too, so you'll be able to look that up there. So all we do is cross multiply. So that's A sine of 30 degrees equal to 6 times sine of 45 degrees. And then how do I get A by itself? divide by the sine of 30. So we need to know, what is this answer? Now you can go to your calculator and try and run this, but it's going to come out to a decimal. That's why we need to know what sine 45 is and sine 30. So we need those angle measures. Do you remember what sine of 45 was? Square root of 2 over 2? Yes. So that's 6 square root of 2 over 2 divided by, what is sine of 30? 1/2. Good. So we just got to do some reducing. That's all that it takes to do the rest of this. So what's going to happen when I take 6 times square root of 2 over 2? It'll be 6 square root of 2 over 2, which reduces to 3 square root of 2 over 2. So our top reduces to that, and our bottom is divided by 1/2, right? But remember, we don't really divide by fractions. What do? You multiply by this reciprocal. So 3 square root of 2 times the reciprocal of 1/2 is 2. And what do we get? That's the answer. So a little bit of mathematical manipulation in the end. Okay? But again, most of these problems in the beginning is the long stuff because it's all that law of sines and law of cosines and plugging in and finding missing angles. Once we get past this stuff and into the vectors, everything kind of picks up the pace. But the beginning of these first few questions are going to take you a little bit because there's some work that you got to do. There are going to be missing pieces that we got to find, like a lot like what you saw right here. We were missing the angle. We had to find it. And then we set up the law of sines, and then we start plugging in what we know. Any questions on this one? Everyone good? All right, question 3. Come on, you. Question 3. What are you doing to me? There we go. All right, so again, we're still on that law of sines. And again, it makes sense because it's just like the last problem. This is angle, side, angle, which is, again, the only way to deal with it is law of sines. So we're looking for B, okay? Actually, we need to find the remaining sides and the angle. So we needed to demolish this triangle, find everything about it. First thing that you're going to want to do, let's find that guy right there. How are we going to do that? Add it together, right? So 180 degrees minus our other two angles, added together. And what do we get for the measure of angle A? Oops. 68 degrees. I'm going to trust you on that. So 68 degrees. Okay? Good. Now we can start dealing with everything else. Now we can find the B and the C. Okay? So let's find B first, because I always like to go in order. What would my law of sines look like setting up B? You always like to put the sign over top. I'm going to put the sign. And it's fine. So Sam likes to put the sign on top. I put the sign on bottom. It doesn't matter as long as you're consistent. If you put the signs on top, you got to keep the signs on top. If you put the sides on top, you got to keep the sides on top. So B over sine 47 equal to what? 15 over 68. Now you see why we had to find that 68. And I should write sine in with that. That would be a logical thing to do. So now all we do is cross multiply and then divide, just like what we did in the last problem. It's always these same steps over and over and over again. So B sine of 68 degrees is equal to whatever 15 times sine of 47 degrees is going to be. And how do I get B by itself? Divide everything by sine 68 degrees. And again, you're going to go to your calculator on this one. And you make sure that you read the fine print, because I believe the fine print in this one says to round to the nearest hundredth. Round to the nearest hundredth. So you go to your calculator, you type 15 times sine 47 degrees over sine 68 degrees. Make sure that you're probably in what mode? Degrees. Check that degrees. What do you get? What is B? 11.83. Perfect. And sometimes it'll ask you about the label, sometimes it doesn't, but just know that we are in meters. What's up? You good? All right, so 11.83 meters. Any questions on that one so far? Again, to find C, we're pretty much going to do the same thing. The only thing that's going to change for us when we find C is that this B over sine 47 will become the other guy, C over sine 65. It's the only thing that changes. All the same stuff over here will still happen the same way. You'll have your sine 47 right here will actually become sine 65. It's the same. That's the only difference. So it's your first fraction changes, which means when we solved right over here, this 15 times sine 47 becomes 15 times sine 65 now. That's the only difference. But I'm going to write it up anyway so you can see that. Quick answer. Yes. So you can see it's pretty much the same fraction. The only difference is just the C is in there now in the sine 65. So you get C sine 68 degrees equal to 15 sine 65 degrees. And in the end, we want to divide by sine 68 degrees. And you're rounding to the nearest hundredth again. So what's C? 14.66. And again, meters, just in case they ever ask you about the label. So always check those. Because I know there is one problem in here that will ask you about a label. Any questions on number 3? So again, find that angle and then find your other two sides. Again, demolish the triangle. Although this time they didn't give you the triangle. So this time we're going to make a picture of this guy. So we've got triangle A. Woo! Screen's flipping on me. Triangle A with little a across from it. If I let the top be big B, that means little b is across from it right over here. No. So that's the triangle that we're looking at. So what case is this? That's angle, side, side. Nope. Angle, side, side. They gave us 2 angles. Oh, we're looking for those. Joking. Joking. As I say, because the ask problem they're going to ask is how many triangles you're going to get. So, just kidding. So we know big B, which is 38.32 degrees. We know big C. Oh my gosh, what is this computer doing? Go away. Yes. So C, 34.61 degrees. And then we know mini C, which is 5 miles. So again, we are looking for the A, the little a, and the B as I had up there earlier. This is just like the last problem. Just like it. First thing you're going to want to find, your angle. And how do we find it? Say it again. Add both of the angles together and subtract them from 180? Yeah. So measure of angle A is equal to this information. So how much is angle A? $107.07. Love it. Degrees. And then finding side A and side B now is just all about setting up those proportions. So what does side A look like? Okay. Side A over sine of 107.07. 5. And again, this will look extremely similar when you do B, except instead of A, it'll be B this time, and instead of sine 107.07, it'll be 38.32 degrees. So when you set up that one, it looks the exact same as what we just put right here. Yeah, it's all the same though. Yeah. 38.32. So that's what the other guy looks like. And in the end, when you cross multiply and do your one division that you have to do, you find that A here is equal to 5 sine 107.07 degrees divided by sine 34.61 degrees. And then down here, your B will be equal to 5 sine of 38.32 degrees divided by sine of 34.61 degrees. So now all you have to do, hold on one second. All you have to do is make sure that you round, and it looks like they want you to round to the nearest whole number. The nearest whole number. So what would A be? 8, and it's in miles. What would the B be? 6? No, B's not 6. It should be 5. Yeah. 5 miles. Let's make sure. Let's double check, because I went through and checked my answers just to make sure. So making sure that I've got this written down right. All right, so let's double check that. Alpha y equals number 1. No, yeah, number 1.
Yeah, this was the
so 5 sine. All right, hold on one second. 38.32, right? On top, divided by sine 34.61. Correct? So, what does the 4 tell the 5 to do? But we're rounding to the nearest whole number. So you have to look at the first decimal. You can't look at the 100th spot, because this affects the 10th spot. That doesn't make any sense. We want to affect this guy. So you look at the next number that's right by it. So the 4 says, hey, 5, stay the way you are. No, that is incorrect. Whatever you're rounding to, whatever spot, you look at directly at the number right after it. That number will tell you what to do. Okay?
It was like probably like this, like 47 and things like that. You could. It was like 40. It was like 47 and things like that.
Yeah.
And, they would just like I was like 47, 47, and then whenever I was 6, I was like, we know which spot.
Anymore. Okay. Yeah, just look at the spot right next to it. Don't go too far down the line because then I could talk down here. Well, then that means the 5 must stay. And then the 5 says, hey, this 3 must go to a 4. Now you're just changing the whole number and doing all sorts of crazy, weird things. Okay? You have to look at the number that's right after the digit you're looking for. So if I'm looking for the 100th spot, then I look at the 8. And it says, hey, 5, go up. And then I'm done. If I'm looking for the 10th, then I look at the 5, and that tells the 4 to go up. But you don't round and then round again. Remember, that's called rounding error. You only round once. And in the end, this 4 says, hey, 5, stay the way you are. Okay? Whoever taught you rounding did it wrong. Yeah. So. All right. So, everyone good on that? Okay. All right, so 5 miles. Jumping into number 5. As you can see, like I said, we're showing a lot of work here, but most of the stuff can be done in your calculator, speed things up. But, again, this is what you're dealing with. So this one says, determine the number of triangles. All right, so this is going to be our ambiguous case. So in the ambiguous case, we need to pretend like it actually exists and start doing all the solving that we normally talked about. Okay? But first things first, let's go ahead and get a picture of this. The ambiguous case is the ask case or the SSA case. So we got big A, we got little a, and we got little b. So this is definitely angle side, side, because we know that this is 43.4 degrees. We know that B is 10.5, and we know that A is 8.2. So this is the ambiguous case. Definitely looking at law of signs. But when you have this case, you have to be careful because in the ambiguous case, you might have no triangle, 1 triangle, or 2 triangles. And that's the question they're asking about here. So that's the question they want us to answer. All right, so what angle are we actually going to figure out because of this case? Who is the angle we're going to figure out? It has to be B, because we know the side and the angle for A, and we know the side, and then we do not know the angle for B. So that everything's going to be based around knowing what B is. All right. So setting up my law of sines, we've got 8.2 over sine 43.4 degrees equal to the 10.5 over sine of B. And again, it's still cross multiplying just like normal. So you'll have 8.2 sine B equal to 10.5 sine 43.4 degrees. And now what are we going to do? Divide by 8.2. So instead of dividing by a sign like what we did earlier, now we just got to actually divide by the number. And in the end, this is what sine will equal. The 10.5 times the sine 43.4 degrees divided by the 8.2. And we'll get to that number here in a moment. But how do I figure out what B is going to be? What do we have to do? You got to do the inverse. So we got to take the inverse of sine. So the measure of angle B is in fact whatever sine -1 of what we just have above here. That's what I would put into the calculator. Yeah, you could actually just find all the original sine B. You could figure that number out and then take the inverse of that. But you could also do it all in one fell swoop right there at the same time too. So this, they round to the nearest tenth since our angle up here, that 43.4 is to the nearest tenth. So what is the possible measure of angle B? 61.6 degrees. Everyone okay so far? So, because of a check that we're going to do right now, we need to check 180 degrees minus 61.6 degrees. We're going to check this. So how much do you get? 118.4 degrees. So, we for sure have one triangle. Okay? We for sure have one triangle. We know it is 61.6 degrees. Okay? Because if this didn't work out, then we wouldn't have any triangle. Okay? So we for sure have one. So we know that. This is the possible other angle in a second triangle. That's why we did this little check right here. This right here is what the other angle possibly could be. How we have to verify that, if this angle is okay, we need to add it with the original A angle. And as long as we are less than 180 degrees, then that means this angle's okay. So right now, we know that 61.6 degrees, that's going to work for us. That's an A-okay angle. Everything worked out. But we got to check this guy. Is 118.4 going to be okay for us? Well, take 118.4, add it with the 43.4 degrees. What do we get? 161.8. And that is less than 180 degrees. So that means we have two triangles. We have one where B is 61.6 degrees. And you have another triangle that exists where B is 118.4 degrees. So this problem, the answer that they want to know, two triangles. Why don't we what? 180 minus the angle? Because there are two angles that allow you that to happen within sine. Okay? So this is that other angle that allows us to be there.
So why wouldn't we get that angle?
Say it again.
Why wouldn't we get that angle?
Because again, it's only going to give you one of those angles because of the restriction. This is outside that restriction, but it's still a freaking out on me. Come back here. This 118.4 is outside the normal sine inverse restriction. Okay? So this is the other angle that exists for sine for us. Okay? You follow me on that? Because remember, when we talked about this, remember that the restriction, I believe, was between, isn't it, pi over 2 and negative pi over 2? So again, this is finding the other guy that's outside that. Okay? It's because of the restriction on the inverse as to why it doesn't give you that guy. Yes. Doesn't work. Doesn't work. Yeah. Doesn't work. Okay? All right. Any questions on this guy? I promise you there is only one ambiguous case on here, and that's it. The only ambiguous case is trying to figure out if you have 0, 1, or 2 triangles. Almost out of law of signs. So now we want to know what is the distance from A to B. We want that information. So again, we're not running the full law of signs. We just had to find the side. But in order to find this side there, just like all the other law of signs, to be a pain in the neck, we got to figure out what the measure of angle A is. And how do we do that? Add the angles and subtract from 180. So the measure of angle A, we need to figure out. So we'll take 180 degrees and subtract off 111 degrees and 13 minutes. Plus 11 degrees, 17 minutes. I would turn some of these to decimals, but the decimals on these don't come out nice. So that's why I keep everything in minutes for this. And again, in your calculator, you can use the minutes too, and I'll show you where that is again here in a second. So what is the measure of angle A? Mm-mm. 57 degrees, 30 minutes. So again, how do you get that? Add the 111 and the 11, you get 122. Okay? Add the 13 and the 17, you get the 30 minutes. But remember that there are no minutes on the 180. So you have to steal a degree to make 60 minutes. So this becomes 179 minus the 122, which gives you the 57. And then 60 minutes minus the 30 minutes gives us the 30 minutes. Okay? Don't forget that you got to steal from the degree to make your minutes for it. All right, so now that we know what A is, now we can actually solve the problem, just like how we solved all the other guys. So how do I figure out my question mark? Because this is still law of signs. Up there you got angle, side angle. Only way to solve it, law of signs. So my question mark is over what? 11 degrees, 17 minutes. Yep. Equal to what? There you go. This is why we had to figure out that angle A, because I'm using it right here. On every problem, they've always had us figure out that one angle, and then we use it. So we do our cross multiplying, and then you do your one division step, and your question mark will come out to equal 365 times sine 11 degrees, 17 minutes, all divided by sine 57 degrees, 30 minutes. And they want you rounding to the nearest whole number on this. Round to the nearest whole number on this one. So let's go into our calculator and let's put this in. So I always like to use my fraction keys. So we got 365 times sine, whoops, I missed my 5. 5 times sine of how much? It was 11. Now all of our degree stuff is under the second apps button. 11 degrees, 17 second apps. And there's your minutes. And it's all over sine, was it 5730? 57 second apps. 30 second apps and minutes. To the nearest whole number, what do we get? 85. Because the 6 says, hey 4, go up. So 85 what? Because this is the one they actually asked the label on. Meters. 85 meters. Cool beans? Just like all the other problems, except they gave us degrees and minutes as time. We are going all the way through. All right, and again, so they want us to figure out the question mark here. They're going to make you work for it a little bit. Again, you do have really angle side to angle. So this is a law of sines problem, even though in the beginning it doesn't really look like it. It really is angle side angle. What do we got to do? Subtract 180 from what? Yes. First thing you got to do, you got to get this guy. And the x and the the x and the 88.9 degrees, they form a linear pair from geometry. And linear pairs always add up to 180 degrees. So to figure out that measure of angle A, you're going to take 180 degrees minus the 88.9 degrees. And that's the angle that we need to work with. How much is that? 91.1? Okay. Everyone good so far? Does that make sense? All right. Now, we need that guy. We need to know what the satellite's angle is. How do I get that? What other two angles? There you go. Good. Yeah, the angle's inside your triangle. So the measure of my, we'll just call it S for satellite, 180 degrees minus, okay, call it C, whatever you want, minus 86.6 degrees plus 91.1 degrees. So what do we get for the measure of angle S or C, whatever you want to call your angle? .3 degrees. All right, so now we have everything we need in order to run law of sines. Okay, so they tried to trick you up with this 88.9 on the outside. Be careful there. They're using a linear pair type idea from geometry. All right, so we're looking for the question mark. You could, yeah, absolutely. It's called an alternate exterior angle theorem. Also works the same way. Okay, what are we going to do now? How do I get my question mark? What the law of sines are going to look like here? Okay. Sine of what? 2.3 degrees. Perfect. Equals your question mark over what? 86.6 degrees, yeah. So all you're going to do is do your cross multiplying and divide by your one sign, just like in all the other ones. So your question mark in this one will look like 654 sine of 86.6 degrees, and then that will be divided by sine of 2.3 degrees. And it says round to the nearest thousandth. Or sorry, not thousand. Thousand. Round to the nearest thousand. Round to the nearest thousand. That means no decimals. You go to the thousand. Yeah, the answer should be something like 1,500, 1,600, 7 to 13, whatever. So what is our answer going to be? It's long. Shouldn't be that long. Should be 16,000. 16,000, what are we dealing with here? Kilometers. 16,000 kilometers. Yeah, because the 2 says, hey, 6, stay the same. Okay? Watch that rounding, guys. That's going to be your biggest enemy on this if you don't round carefully, okay? All right, so that ends law of sines. That ends the law of sines. That's 11.1. So the next questions from 8, 9, 10, 11, 12, 13, 14, and 15. These are all 11.2. So right here, half of your exam is 11.1, 11.2. Half of the exam, 11.1, 11.2. There will be no 11.7. All right. So let's hit up what's going on. Ready? So these problems will be a little bit longer because of the law of cosines formula is horrendously long. All right. So first things first. If the values of A, B, and little c are known, what kind of arrangement is this? So this is a lot like question number 1. What do we got here? Side, 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 angle, side, 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 angle, side, things like that. So let's draw our quick picture. A, B, C. What do we have? We have angle, side, angle. So that's the answer to the first part. And on your test, again, it'll be multiple choice. They'll have all the pieces written. You just select the one that will be correct. Now they want to know, because you have angle, side, angle, who do we run? Law of sines or law of cosines? Say it again. It is actually law of sines. You've been running this kind of formula for the past few problems. All the past problems have been law of sines, angle, side, angle. Well, let's talk about when we run law of cosines then real quick, since this is the new stuff. When do we run law of cosines? So when we have side, 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 or when we have what? There's one other piece. Nope. Side, angle, side. So you run law of cosines if you have side, angle, side, and side, side, side. Other than that, if it's not those two, it's law of sines for everybody else. Okay? Except for angle, 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 you don't run anything for that because you can't do it. Can't do anything with angle, angle, angle. All right, so let's jump in where we're actually running the formulas. So they want the exact length, so not using the calculator. So remember, the law of cosines, the side you're looking for, or the angle you're looking for, they have to be across from each other. Okay? So in this case, since we're looking for A, that means the angle will be about the 60 because they're across from each other. And vice versa. If you're looking for an angle, you have to get the side across from it to be the equal part. What's up? The only thing I'm putting up on the board are the trig functions chart. So whatever you want on your little note card, that's up to you. Okay? So this is a squared equals, well, we start plugging in everybody else. Remember, that's going to be your b squared plus your c squared minus 2bc cosine of angle A. That's what the full law of sine or law of cosine looks like for this. Again, because this is side angle side, that's a law of cosine idea. So we just plug in what we know. We don't know A, so that's a squared. B can be either 6 or 16. It doesn't really matter at this point. So 16 squared plus your C is 6 squared minus 2 times your 6. So minus 2 times your 6 times your 16 times cosine 60 degrees. So that's what it looks like with everything in there. But we know what cosine 60 degrees is. What is cosine 60 degrees?
Something that you're going to be putting up on the board on your step.
1/2. So all you have to do is go into your calculator and square this number, add it with the square of the next number, and it's subtracted from 2 times 16 times 16 times 6 times 1/2. Okay? And then all you got to do in the end, well, actually, let's get that number real quick. What do you get when you multiply all that? 50? 16 squared plus 6 squared minus the 2 times the 6 times the 16 times 1/2 is not 50. How much? 196. Should be 196. But remember, that's what a squared is. So it's 14 because you got to take your square root. Cool beans? Just be careful running it in your calculator. Tatiana, you good? Does it make sense? Times 0.5. There you go. Okay. All right. So again, this time we're finding the angle. So who does this thing have to be equal to? If we're looking for this guy right here, what side does it have to equal? Which number is it going to be? Because for the law of cosines to work, it is very, very specific about who goes where. And we have to use law of cosines because it is side, side, side that's going on. Well, we're going to use that formula, but you got to know who goes first because you can't just pick anybody. Law of cosines is very picky about who's going first, and that's what I said. It's whoever's across from it. Say it again, Geta. Yeah, it'll be this guy right here, the side that is across from it. So this has to be 4 squared equals. And it's that 4 that I boxed in right over there. It can't be anybody else because of where the angle's located. You follow me on that? And then you just fill in the rest of the stuff. So it'll be that b squared, well, whatever side you want to call this guy. Doesn't really matter, but it'll be the 4 squared plus 4 squared to 3 squared, and then minus 2 times 4 times 4 square root of 3. So it's going to want us to come out with a nice, neat answer for this. So that means this is going to be a trig function that we do know in the end. So we got to do some running of some different things here. We know what 4 squared is. What is that? 16, which is 16. And we know what 4 squared to 3 squared is. What is 4 squared to 3 squared going to be? 48. So you square the 4, that's 16. You square the radical, which becomes just 3. And what's 16 times 3? 48. And then what's 2 times 4? Times 4 squared to 3. How much? Just take the 8 times the 4. Take the 8 times the 4. What is 8 times the 4? 32 square root of 3 cosine theta. You can't just go into your calculator. Yeah, be careful. So now we got to get cosine theta by itself. So what are we going to do?
Subtract both sides by 16 or 48.
Yeah. Take these guys right here, subtract them to the other side. Let me fix this since it didn't want to write very well.
You just don't want to write.
Maybe you don't know how to write.
So what do we get on the left-hand side? Negative 48. Perfect. And on the right side, we still got negative 32 square root of 3 cosine of theta. Now what are you going to do? Yeah. Divide both sides by the negative 32 square root of 3. Now, first, reduce your numbers here. What is negative 48 divided by negative 32? What does that become? Well, actually, let's just go back. Let's do something else. Well, but we got to get the exact answer, though. I know. But just so you know where it's coming from. If we rationalize this, what are we going to do first? Uh-huh. So you get negative 48 square root of 3 all over what's really on bottom now? Negative 32 times 3, which is? Negative 96. All right. So now, if you take negative 48 divided by negative 96, that reduces down to 1 over 2. So what you're looking at is when is cosine square root of 3 over 2? And you will find 2 answers, but only one of them makes sense because one of them is outside the realm of being an actual triangle. 30 degrees? Yeah. It's fine. It's fine for right now. Giving you chills? Good. It's fine. I don't know how to do it on this board. All right. So, question 11. Back to those word problems, but again, it's still doing the same thing. You're going to be looking at either side, 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 or side angle, side. So if I draw a quick picture of this, so it says a triangular swimming pool measures 46 feet on one side. Okay. How do I draw my triangle? I just put the 46 down here. Doesn't really matter where it goes. Okay, and it says it is 32.8 feet on another. So 32.8 feet. And it says the two sides form an angle that measures 41.2 degrees. That's what we're looking at. And you definitely see that it's side angle side. Which again, we have to use law of cosines. Like I said, these first beginning 15 problems, these are the longest because you're just doing a lot of formula work. A lot of just plain Jane algebra. All right, so they want to know how long is the third side. They want that guy. So, how are we going to set this up? Say it again. But 41.2 is an angle. Can't square that. That's got to be with your cosine. It will be question mark squared. Absolutely. And with that question mark, that's why we have the 41.2 degrees, because they're across from each other. And then everybody else now goes in for your A, B, C's, whatever you wanted to call those letters. So you got your 32.8 squared plus 46 squared minus 2 times 32.8 times 46. So that's what it really looks like. All you got to do is go put this into your calculator and get whatever number this thing kicks out, and then take the square root of it. Just type this into your calculator the way you see it, and once you get that answer, take the square root of it, and you're done. And you're going to round to the nearest tenth. You're going to round to the nearest tenth. What do you get? 30 point what? 1? Nope. 30.4. 0.4 feet. And again, in here, they'll give you another question where it says, what's the label? So 30.4 feet. Because if you work this number out over here, before you take the square root, you should end up with, in your calculator, the number 921.3527709. And then once you take the square root of that, that's what pops out. Okay. All right. Question number 12. So again, back to an angle. So everything we're doing in this is all based on side, sine. So again, it's that law of cosines. So, what is our equation going to look like? What is our law of cosines going to look like? Yes, good, because it is across from the angle, so that means we have cosine theta again. Equal to, and then everybody else goes into whatever your other spots are. So, good, because they're across from each other. So you got 9 squared plus 9 squared minus 2 times 9 times 9. And in this guy, in the end, you'll be rounding to the nearest degree. That's what they want. Round it to the nearest degree. So you're definitely going to be doing some solving on this. So hopefully this is what it's beginning to look like. How do I start to get cosine theta by itself? Minus 81, minus 81. And what is 49 minus 81 minus 81? Perfect. And that's equal to negative 162 cosine theta. Then what are you going to do? Uh-huh. And so you end up with cosine theta equal to 113 over 162. Now how do you get what theta is? Do the inverse. There you go. Take cosine negative 1 of that fraction. And theta, rounded to the nearest degree, is how much? 46 degrees. Again, you're seeing a lot of work on this, but when it comes to your test, you don't have to show half as much work. Most of the stuff I would be typing in the calculator, letting it do the dancing for me. Okay? Everyone good on that? Feeling okay? Cadell, you all right? Where did I lose you? Well, we got to get theta by itself, so how do you get rid of cosine? You take the inverse of it. Okay? Just like before when we wanted to solve for sine theta, how do we get rid of sine? We take the inverse of it. Okay? Good questions. Good questions. We're almost out of law of cosines. All right. So they want to know what is the distance from house A to house B. That's what they want. So again, you're looking at angle, side, angle here. So, sorry, I said angle, side, angle. That is incorrect. Side, angle, side. Yeah, right? Law of sines. I know, right? Law of cosines. No different than what we've done before. What is our equation going to look like? Question mark squared. And again, you can just go straight into your calculator, figure out this number, and how do you get rid of something squared? You take the square root of it. So just like the one that we did before this. Go into that calculator, let it do the hard work for you, and then all you got to do is take the square root of that answer in the end. And they want you rounding to the nearest hundredth on this one. Rounding to the nearest hundredth on this one. How much? 33.36 is correct. Feet. And again, the number before you take the square root, you should have found that it was 1,112.691458. That's straight from the calculator. And then all you do is take the square root of that number. Yeah, you can also type it under square root. I'm just letting you know, though, before you took the square root, if you were solving them separately, that's the number it should have come out to. Any questions on number 13? Just law of cosines repeated. All right, 14 and 15, these are going to be all about the area formulas. All about the area formulas of triangle. One of the questions is dealing with the area formula when you have side angle side. The other question is dealing with the area formula when you have all sides known. And that was Heron's formula. This guy is the side angle side one. So remember that there were three formulas, and they're pretty much all the same. All that changed is just the two sides we were working with in the angle. But they all run the same. Area is equal to your side times your side. Let me write this better. Hold on one second. Your side times your side times a half times sine of whatever the angle is. That's pretty much how that formula all paired out. Your two sides times a half times the sine of the angle between them.
So we can only run the area formula that we have side equal side and we have side side.
If you are using trig, yeah. Trig can help you run those triangle formulas. In these cases, yes.
So it's not going to ask like,
it's not going to ask you anything outside these two questions. You're going to be just fine, Sam. So we just plug in what we know. One of our sides is 10.3. Another one of our sides is 6.5. We have a half. And we have sine of 10.1 degrees. Go into your calculator and let it kick out the answer for you. And they want you to round to the nearest tenth on this. Round to the nearest tenth. So the area is about what? Big old number. No, not really. To the nearest tenth. Say it again. 5.9. When you say 6, that means you're rounding to the nearest whole number. So the tenth is one decimal spot. So you look at the decimal right next to it. What decimal is next to the 9? It's 10.1, not 10.3. So 5.9 what? Meters squared, because it is area. Okay? Watch the numbers you put in. Everyone good? Number 15 is different because this time it's side, side, side. So this one we're going to use Heron's formula. Now remember with Heron's formula you found this S, which was called the semi-perimeter. To find that semi-perimeter, remember you take a half times A times A plus B plus C. You find that first because we need to know what S is. This is what we call the semi-perimeter. So what is the semi-perimeter? Say it again. 135.7. Because again, you just add up all your numbers and then multiply it by a half or divide it by 2. Now, we're not done though. Because now that we have the semi-perimeter, we can actually run the area formula, which looks like this. The square root of S times S minus A times S minus B times S minus C. So that's the area formula for side, side, side. So all we do is we plug in. So that would be 135.7 times 135.7 minus your A value, which was 105.7, times 135.7 minus your B value, which was 74.3. Let's write that a little bit better. And then we're going to subtract off 135.7 minus your C value, which was 91.4. Once we get that number, we take the square root of it. And they want you rounding to the nearest whole number. To the nearest whole number. So again, you just let your calculator do the dancing for you. To the nearest whole number. And what do you get? $3,328 what? What are we dealing with here? Meters squared. Because again, before you take your square root, the number that you're looking at is 11,073,201.42, and then you take your square root of that, and that's what gets you to this number. 11,073,201.42. Any questions on herons? Everything that we've been doing up to now, it's formulas, plug and chug. We'll do a look. You'll still have a couple more formulas on this, but we're not doing anything crazy here. Law of sines, law of cosines, little side angle side area formula, a little bit of side 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 heron angle formula, or excuse me, area formula. All right, we ready to move to the last half of this stuff? You can kind of now see why I didn't have time in class really to hit everything up. Because these problems, in the beginning, they're long. All right. So, here's our vector B. Which one shows negative B? B, absolutely, right there. You draw it in the, no, that's not on purpose. You just draw it in the opposite direction. Okay? Everyone good so far on that? Yeah. I don't think there's any follow-up question to that. Nope. Just that guy, B. Cool beans? All right. See, like I said, now we're going to start picking things up. Question 16, let me go ahead and tell you again where everything's laid out. 16, 17, 18, 19, 20, 21, 22, 23, 24. Those are all 11.3. 16 to 24, all 11.3. And then from 25 on through the end, that's 11.6. Okay? So that's what we have left. You're going to see what you need to know. We're going to get to that. This, yeah. There's an answer key that will be posted online for the review that you're watching right now. The video that we're making right now will be posted online. Everything we're doing right now will be out there. Okay. Yeah, absolutely. It's all going to be out there. I think so. Pretty sure. Yes, 8 through 15 was 11.2. All right, so this guy right here. So again, we're adding vectors. So remember I told you there are two ways to add vectors. You can draw your vector in. So that was my A. And then from the very end of A, I can pick up and draw my B in. And the guy starting from here, drawing out to B, the end of B, that's A plus B. Okay? So, kind of looking at these things, this guy right here in the middle tried to do that A plus B the way we drew it, but what was the problem with this one? Well, not just the arrows, but it started with which vector? It started with B first and then did the A, and that's incorrect. You have to go in order of the vectors they give you. They want A first, then the B. This guy did that. It did A, then the B, but what's the problem with it? Yeah, the arrow's in the wrong spot. It's pointing at A and not starting at A. So that's why these guys are out. Does that make sense so far? Okay. And then, really, in the end, you can look at this next guy and know that that's not going to be right, but we'll talk about why it's not right here in a second. The other way that you can add these is you can draw in your angle A, or excuse me, your vector A, draw in your vector B, where they both start at the same spot. Not like that, though. Let's make it a little bit straighter. And starting where they both connect and filling in, sorry about that, and filling in the parallelogram that they form, drawing in that diagonal right there, that's A plus B. So if you look at the third guy that's right here, you can see that that doesn't even match what was going on because it's not even going from where both of them started. So the only correct answer, the only logical one, was the first. Was A. Make sense? You just got to look at your picture, and it could be either one of these. That's why I'm showing you both. You got to see which picture is it the one that they're giving us, and in the end, they've given us the diagonal one where we complete the parallelogram. What? Why could it be either one? Because there's two ways to draw vector addition. One where you connect from the beginning to the end of your two vectors being added. Another where you connect the diagonal of the parallelogram that's made. They're both the same. Okay, so this guy, they're giving you all these horizontal and vertical vector components, and all we need to do is perform the operations that are over here. Now, remember in class I told you there are two ways to deal with this. You can deal with them with their i's and their j's, or you can turn them back into the vectors they are. So vector u is really what? What is the vector form for vector u? Seven comma 0. Because the 7 represents like what I call the, again, the x component, but it's not really an x value. And since there's no j, that represents the y component, but that's not really the y component. That's not what it is. But it acts like it, but it's not. But you can take it as that. Yeah. So vector v is really what? 6, 4. And you could treat it as the vectors and do the same thing. These all work the same way, whether you treat it as if it was the vector or if it's in component form. Okay? So 5u, you can think of it as one of two ways. 5 times whatever u was, which is 7i, which gives us what? What's 5 times 7? 35. Mark, you're awfully quiet today.
Oh, Mark. You okay there? So far, good?
So there's your answer. Or if you dealt with it as a vector, it would look like this. 5 times 7, comma, 0. And again, it's like distributing through there. You would get this, which is 35, comma, 0. And then you would just turn that back into the i's and the j's that represent them. Okay? Either way is correct. I'm just going to deal with them as their i's and j's from here on out. But you can always deal with it in their vector component form. All right, so here we got 5, and we're going to multiply that by vector u, which is 7i. And then we've got plus 7 times vector v, which is 6i plus 4j. So what's going to happen with the first 5 times u? 35i, perfect. Plus, what's the 7 going to do to this? 42i, okay? And 28j. And now what are you going to do? Yeah, it's like combining like terms, right? Put the i's at the i's. So what do we get? Like factors? Say it again. 77i plus 28j. Does that make sense? Okay, and then they just want you to do it again for number C. So this time we have V first, which is 6i plus 4j. And then we're subtracting 7 times u this time, which is 7i. So does anything happen with my first 6i plus 4j? Nope. There's nothing multiplying it. So 6i plus 4j. What is 7 times 7i? 49. $49i, and in the end, all you got to do is put your like terms together, and what do you get? No. Negative 43i plus 4j. Because 6 minus 49 is negative 43. Cool beans? And that's what they want. Basically, some simple vector scalar multiplication, some adding and subtracting. That's all they want you to do. Any questions on number 18? Cool beans? Yeah, like I said, once we get past law of sines, law of cosines, these problems get a little bit shorter and a little bit faster. All right, so again, it wants vector adding and subtracting. We're going to take vector 0, comma 1, and we're going to subtract vector 4, comma 4. So a minus b is equal to what vector? Negative 4 and negative 3. Because you take these guys and subtract them. 0 minus 4 is negative 3. And you take these two and subtract them. 1 minus 4 is negative 3. Did I say 0 minus 4 is negative 3? Yeah. Sorry, 0 minus 4 is negative 4. And then 1 minus 4 is negative 3. Like, again, combining like terms. Okay? Moving on. Almost there. So, they want you to write the vector form of this. So we need to figure out A and the B. We have formulas for those. What's the formula to figuring out A? Magnitude of what? Of our vector, okay. Whatever it is, we'll just call it U. Cosine of our angle, right? What is the formula for B? Magnitude of U. Sine theta. A lot like our polar coordinates, where you had R in the angle. So all you got to do is plug in. What's the magnitude of our vector? 2. What's our angle? And we know what that is. We can figure that out. We know what cosine 60 is. 1/2. So we're really just taking 2 times 1/2, which is what? 1. So our vector starts with 1 comma, and all we're going to do is do the same thing again. Our magnitude hasn't changed. It's not absolute value. It is magnitude because these are vectors. Remember, think Despicable Me, the bad guy, vector. He is committing crimes with both magnitude and direction. So here, we're going to take 2 times, we know what 60 degrees is, sine 60. What is that? Square root of 3 over 2. And what do I get when I multiply those two? Square root of 3. So there's your vector. Everyone good so far? All right. So, again, they want you to write the vector. But this time, it's not nice for us. So, A equals, what's our magnitude? 3. And it's going to be the cosine of what? Negative 80. And they want you rounding on this to the nearest thousandth. Thousandth. So what is A? There you go. 0.521. Okay. Our magnitude is still 3, but this time it is sine negative 80 degrees. And to the nearest thousandth, what is 3 times sine negative 80 degrees? Perfect. So your vector, once you put it in, would look like this. 0.521, comma, negative 2.954. Fix that 9. There we go. There's your component form. All right, almost out of this section now. Just a couple more. 22. So they want you to find the magnitude and the direction. Again, formulas. How do we find magnitude of a vector? Yeah. It's like your Pythagorean theorem. It's like you're taking the square root of your x and your y component. So, what is 3 squared? Or square root of 3 squared? 3. What's negative 1 squared? What's 3 plus 1? 4. And what's the square root of 4? 2. Now you know the magnitude. To find the angle, how do we do that? What's the formula for the angle? So tan theta is equal to B over A. So tan theta equals, what is our B value? Over the square root of 3, because that's your A value. And we actually can figure this out if we rationalize real quick. We're really looking at knowing what tan theta equals negative square root of 3 over 3. That's what we're really concerned with. So in other words, how do I get theta by itself? Inverse. So we want to know, when is the inverse of tangent equal to negative square root of 3 over 3? And they do want the nice answer to this. Of what? 330 degrees. And again, we know it is 330 degrees because you also have to take into account where your vector is located. So there really are two angles that are in tangent that are negative square root of 3 over 3. But we're going to choose the 330 degrees because this vector is in quadrant 4. That vector is in quadrant 4. So, which makes sense why it's 330 degrees. Because the other angle that occurs does not take your vector into quadrant 4. Make sense? So that's what they're looking for. The magnitude of 2 and the angle, which is 330 degrees. All right, question number 23. So they want the angle between these two guys. Okay, between these two vectors. So, a couple things that can help us out. What does this first vector, let's just call it U, really look like? These are two vectors. This is the guy I'm going to call U. This is the guy I'll call V. 3 and negative 1. What does vector V really look like? 0, 1. Good. All right. So there's a formula to find the angle between two vectors. What is that formula? It's a what? Cosine of theta is equal to? Okay, so we look at the dot product. Okay, you got it. Magnitude of the U times the magnitude of V. Okay. So the first thing we have to do is we got to figure out magnitudes. And the dot product, absolutely. So let's get magnitudes first. So remember, magnitude is just that square root of A squared plus B squared. So that's 3 squared plus negative 1 squared. And what is the magnitude there? No decimals. Going to have to keep it exact for right now. No, what's 3 squared? 9. And what's negative 1 squared? Square root of 10. What did the what guy do? Nope. Nope, because of the addition, you can't do that. You actually have to run it. Think PEMDAS. The square root acts like a giant parenthesis. Yeah, if you had something like this, well, God, this board is horrible. If you had something that looked like gibberish, like that, then the square root cancels the square. But it doesn't work the other way around. All right, so there's our magnitude of the first guy. Now we need to get the magnitude of V, which is 0 squared plus 1 squared, which gives us what? Square root of 1, which is 1. That we know. So now we know our magnitudes. 1 is the square root of 10, and 1 is 1. Now we need to get their dot products. So we're just going to add that down below here. U dot product V. Do you remember what the formula for dot product is? So the formula for dot product is like you're going to multiply the x parts, and you're going to multiply the y parts, and then you're going to subtract those, no, excuse me, you're going to add those two pieces. So the formula that I gave you in class looked like this. AC plus BD, where the A and the B came from the first vector, and the C and the D came from the second vector. So, what is our A from the first vector? What's our A from the first vector? Or in other words, the X. 3. What is the X or the C part from the second vector? 0. So we're going to take 3 times 0, and we're going to add that's horrible. We'll just cross that piece out there. What is the B part from the first equation? What is the D part from the second? So we'll take negative 1 times 1. So what is 3 times 0? 0. And what's negative 1 times 1? You worry me. What's negative 1 times 1? Negative 1. Whew. This is the easy stuff, guys. So what's 0 plus negative 1? Negative 1. Now you know the dot product. So all we got to do now is take these 3 pieces that we found and plug them into the equation that we had at the very top. So we will have cosine theta equal to, what was the dot product? Negative 1. What was the magnitude of u? Square root of 10. Freaking marker. And what was the magnitude of v? Okay, so let's do some reducing. What is the square root of 10 times 1? Square root of 10, right? So we've got negative 1 over the square root of 10. Now let's rationalize. So we multiply top and bottom by the square root of 10. And so cosine theta really equals what over what? negative, all over what? 10. So how do I figure out the angle now? Inverse of cosine. You got it. So you just go straight into your calculator and you tell it cosine inverse of negative square root of 10 over 10. And you're going to round this angle to the nearest tenth. You will round this angle to the nearest tenth. Nearest tenth. 108.4 degrees. There's our angle. Any questions? Again, it's running your formula and just picking those pieces and plugging it in. Plug and chug. Last question out of 11.3. They want to know if these two vectors are orthogonal. Orthogonal means that they're perpendicular to each other. In order to find out if they're perpendicular to each other, what needs to happen is you'll run the dot product. And as long as it equals 0, they are orthogonal. Okay? So, let's run the dot product. What is the A value in the first? 1. Times, what is the A value in the second? Square root of 2. And remember, we're going to add that with, what is the A or the B value in the first? The negative 1. And we're going to multiply that by what is really your D value in the second? Negative 1. So, what's 1 times the square root of 2? And what is negative 1 times negative 1? So if I take the square root of 2 plus 1, will that be 0? So are they orthogonal? No. Because it's not 0. All right. Now on to the last piece, 11.6, where everything is now polar. So you might want to go into your calculator and switch into polar mode now. So from 25 on down, calculator needs to be in polar mode. So remember, you go under mode, take it on back down here, and scroll over past parametric into polar mode. Hit second mode, and you're good to go now. All right. So first thing says, which of the points is not equivalent below? All right. So the first thing that we need to do, remember in class I told you, go ahead and figure out those 4 equivalent points that we made before, the 4 polar points. So we're going to have 4 of these. Where 2 of them we add 360 degrees, and 2 of them where we will add or subtract 360 degrees, and 2 of them where we will add or subtract 180 degrees. Okay? So, what do you want your first R to be? What do you want the first R to be? Remember, this is R followed by, this is your R followed by your theta. So what do you want? Say it again. 9. Okay. So she's given us the opposites. So what does that mean I do with my angle? Do I add and subtract 360 or do I add and subtract 180? Say it again. Nope. When you do the inverse, you add and subtract 180. Okay? When you are looking at the inverse kind of vector of it, the inverse r, you are adding and subtracting 180. So what is 150 plus 180? What's 150 plus 180? So there's 1. And what's 150 minus 180? Negative 30. So there are those two. Okay? Now, what would the other r be for this guy? This one, you keep it the same. And when you keep it the same, that's when you add the 360. Because we want to return right back to this vector. So we're going to take 150 and add 360. How much? 510 and negative 210. All you got to do is look over here and find the one that is not listed over there. And is it A, B, C, or D? C. Down below here it says what is the rectangular coordinates. So this is going to look a lot like when we were finding those vector coordinates, like A and B. So do you remember what the formula to find x was? It's a lot like our vector formulas we just talked about a couple minutes ago. R cosine theta, which if we were in vectors, that would have been magnitude cosine theta. How do you find the y vector, or the y part? R sine theta. So all we got to do is just run these two quick formulas. So x is going to be negative 9 times cosine 150 degrees. And we know what cosine 150 degrees is. What is cosine 150 degrees? So you're taking negative 9 times negative square root of 3 over 2. And what do you get? No decimals. It's got to be exact. 9 squared root of 3 over 2. Yeah, got to be exact. If they want the decimal, it will tell you in the little fine print directions right below it to round to whatever. Okay? All right. The y value. So we're taking negative 9. This board is so weird. Negative 9 times sine 150 degrees. But again, we know what sine 150 degrees is. Say it again. 1/2. So what is 9 times a half? Negative 9 over 2. There is the rectangular coordinate. Okay? But we're not done. So now they want to know which is the picture of the graph. So A is not correct. B, it'd be B, is not correct. All right, because it's -9, remember that's an inverse. So this guy right here is when your vector is a +9, because that's 150 degrees. But remember, it's a -9, so it has to be C, because that's where you see this vector right here of a -9. Say it again. Well, it all depends upon where your vector is rotated around. What if it was -150? So then your graph would have looked like, well, it's not even up here. But if it was -150, it would have started out like this. You would have had this vector for the +9, because that is -150 degrees. And then you do the opposite side. So that would be the -9. Close, as close as what I could draw it. You get what I'm saying?
Yeah, I just think that, like, usually when we graph
Yeah.
negative on the left, we have to do those opposites.
Yeah. All right. 26. Here we go. So the first one says, which graph represents it? Okay? So again, pi/3. We know what angle that is. What is the angle of pi/3? 60 degrees. So first we need to find one that goes 60 degrees. So this guy right here looks like it's 60 degrees, right? And again, but that's for a +2. So I need to make the reflection of that the inverse. So the answer has to be A. Cool beans? All right. Then down here, all you're doing is the same thing that we did on the front side, but we don't have to create all 4 angles. We just want a very specific one. So this guy right here, for our polar coordinate, and you're going to have to leave this in radians. This is like your only radian problem in here. It wants your r to be less than 0. So does that mean we keep our r -2, or do we change it to the positive version of 2? Keep it. So since we're keeping it -2, that means do we add or subtract 360, or do we add or subtract 180? This is 360 because we're keeping it the same. But in our case, it's all about pi, 2 pi, right? So we want to be between 2 pi and 4 pi. So does that mean I will add 2 pi or subtract 2 pi? Add it. Because we want to be between these two guys, that means we want to add it. So we need to take pi/3 plus 2 pi. What do you get? Say it again. 7 pi/3. Perfect. There's that polar coordinate. And then roughly the same idea again down here. So this time we want r to be greater than 0. So am I going to keep it a -2 or make it a +2? So this is the inverse. And because we're using the inverse this time, will we add or subtract 360 or add or subtract 180? This is the 180. But again, we're in radians, so we want pi. So will we add pi or subtract pi since we want to be between 0 and 2 pi? Add it. So you'll take pi over 3, and we want to add pi to it. 4 pi over 3 is correct. There you go. Cool beans?
Yes.
Good. I'm glad you agree. 27. So we want to convert this from the rectangular coordinate into the polar coordinate. Okay. Again, what do we know about x? It equals r cosine theta. Good. What do we know about y? R sine theta. So all you're going to do is plug in what you know. Okay? So we see in x, r cosine theta minus r sine theta. Good. Equal to 8. But remember, these equations, in the end, they have to be equal to r. So what are we going to do to start getting r by itself? Okay, because both of these have r in common, right? We don't divide yet. There you go. Take the r out. It's like a GCF. Pull the r out of these two. That will give you cosine theta cosine theta, if I could ever get this board to act right sometimes, minus sine theta equal to 8. And then now we can do your idea, Tatiana, that you wanted to do. Now we can divide, by the cosine minus sine theta. And that's your answer. Cosine theta minus sine theta. Cosine theta minus sine theta. So that right there is your answer. 8 divided by cosine theta minus sine theta. That's your R. Cool, cool? Okay. Oh, we can see the finish line. It's coming closer. So this right here, let the calculator do the work. Go into your calculator, plug this thing in, and see which picture. Yeah, you better make sure that you're in polar and see which picture it is. So 6 cosine 2 theta. So you hit your y equals, which is now in polar. 6 cosine 2 theta. Uh-oh, what happens when my window doesn't graph it? What do I got to do? Zoom standard. Zoom standard. So 6, and there it is. So which picture matches that one? A. So has to be that guy right there, which was A. Oh man, we almost did it. On number 29. All right. So, again, we can go into our calculator and let it graph this for us. But remember, there's one little thing that you have to be careful of. This is r squared. How do I get the r by itself? Square root. So, remember that you will have 2 r's. Because when you take a square root of both sides, you slap plus or minus in front of it. So you will have one equation that is a positive square root, and one equation that will be a negative square root. And it will be the square root of 64 cosine 2 theta and 64, not 66, cosine 2 theta. And again, you just go into your calculator, plug those two guys in, and it will show you which picture. It will show you the first one. And do you remember what the name of that guy was? There are two L's. Lemniscate. Huh? Oh, no, I mentioned that in class. Oh, the limicon? Yeah, I didn't talk about that. So do you think it's going to be on your test? No. Right? Yeah. Careful. The square root of 2 doesn't come out to just cosine theta. Careful of that. Well, it may not work in every case. You must be careful. Yeah. Yeah, just put it in the way. Because most of you will probably say, hey, I know what the square root of 64 is. That's fine. Square root of 64 is 8, but you got to be careful here because that square root still needs to remain over the cosine 2 theta. Because it doesn't become cosine theta because that's not a squared cosine. That's a double angle cosine. There's a difference between a squared cosine and a double angle cosine. And besides, the square root of 2 is not 1. So you lucked out on that. So you did some math magic and it worked, but it may not work all the time. All right, and the last guy. Here it is. The end. We need to take this guy and turn it into its original equation. And then we'll figure out which picture it is down below. So again, what do you remember about x in polar coordinates? R cosine theta. What do you remember about y in polar coordinates? And there was one other piece that I taught you. R squared is equal to what? All right. But also remember, you can also talk about it as R equals the square root of x squared plus y squared. Somehow we're going to use these to help us. Maybe we use all of them. Maybe we just use a couple of them. So how can I start dealing with this r equals 10 sine theta? It almost looks like what? Who do we almost have there? We almost have y. What's it missing? Well, it's missing the y, but what is it really missing up there? No, it's missing an r by the sign. So what do we got to do to both sides? Multiply both sides by r. You get an r. And you get an r. So what's r times r? R squared. Equals. On the other side, we get 10 r sine theta, right? And now we can start using things that we know. Don't we know what r squared is? X squared plus y squared. Don't we know what r sine theta is? It's y. So over here, you get 10y. Now, we're not done, though. We need to move this 10y over to the other side, and you're going to complete the square. Because this thing is a circle, as you can see in all the pictures down below. So, I need to move this over to the other side, so I'm going to subtract it. So we get x squared plus y squared minus 10y equal to 0. Complete the square. So remember, we got to find that c value. How do we find that c value to complete the square? B divided by 2, square it. What is your b value? The negative 10. So what is negative 10 divided by 2. Negative 5. And what is negative 5 squared? So what's going to get added to both sides? 25. Really? So we add that 25 to both sides. And now we know what this basically comes out to be. X squared plus something squared equal to 25. What does that y part factor to? Y minus 5. There you go. So there's your equation. So which one up here matches that equation? C? Yep. Because we know that 25 is really 5 squared in disguise. Yeah, scroll back down. So this whole part right here, that's why we completed the square to make it factorable, which gives you the y minus 5 squared. And then now, all we got to do is just figure out which graph it is. So if you remember about circles, you've got H and K, which tell you the center. Let me zoom back in on this. H and K, which tell you the center. So what is your H value? 0. What is your K value? Positive 5. And then what's your radius? So I need a circle that has a center of 0, 5 and a radius of 5. And that's going to be D.